Thank you all for standing by, and welcome to today's webinar, Managing Microservice Deployments on AWS with HashiCorp Consul. Please feel free to type in your questions during the webinar. This webinar is being recorded, and the recording will be made available after post-processing, usually within 2 days. Our speakers today are going to be Mishra, our developer advocate from HashiCorp, and Nathan Peck, developer advocate from AWS. And with that, we'll go ahead and get started. Okay, Nathan.
Hello, everyone. My name is Nathan Peck. I'm developer advocate for container services at Amazon. And I want to start out, first of all, by introducing the container services that we have available at Amazon, in particular AWS ECS and AWS Fargate, because that's what we'll be using for the demo of showing how to run Consul Connect for microservice mesh. So to begin with, the first thing to understand about containers is that they've really become the standard for how you should ship and run your application to the cloud. There's a lot of reasons why this is so, but basically it helps you package up your application reliably, take your application, all of its dependencies, and get them to the machines that you plan to run your application on, as well as vertically and horizontally scale your application, in particular, being able to put multiple applications onto a single server to get good utilization to save money. So as containers have grown, what's really been discovered is that managing containers by hand is inefficient and error-prone. So if you ask your developers to, say, take a large pool of instances and run a bunch of containerized applications, either many copies of a single application or many different applications, they're going to end up making mistakes. They're going to have to spend a lot of time making sure things work. Well, what if an application has crashed and needs to be restarted? How can we make sure that that application is hooked up to all the different resources that it needs and has the ability to talk to other backing services that it requires? So one of the solutions that's arisen to solve this problem is container orchestration. And basically the idea of container orchestration is that I can give my container orchestrator a pool of instances to run on. So I can say, here's a cluster of EC2 instances. They don't have to be all the same type of instance. They could be a variety of different instances. Some could be spot, some could be reserved, some could be on-demand instances. They could be instances of different types. But I just give them all to the orchestrator and say, this is the capacity that I have available that I would like to make use of to run my application. And then I give the orchestrator a high-level intent, which is something like, I would like to launch 10 copies of this container distributed across 3 availability zones, and I want to hook them up to this load balancer. And Amazon ECS accepts that as a single API call, which will then go out and fulfill that request by talking to all these different hosts and making sure that they actually launch those 10 copies, that those 10 copies are distributed, and that they're hooked up to a load balancer. So at a high level, you can think about container orchestration as a way to simplify your life when it comes to operations, because rather than having to go in there by hand or write a bunch of scripts to accomplish some of these tasks, now the container orchestrator can just take your API command and do all that for you. But one thing that we notice with a system like this is that running your cluster itself still requires a lot of work. So provisioning all those EC2 instances under the covers that you would give to your container orchestrator, you have to patch them, you have to upgrade them, you have to make sure that if there's been a new CVE and underlying operating system or library that you fix that. You have to make sure that those hosts are running Docker itself, the Docker agent, the ECS agent side of the container orchestrator can communicate to them and control them. And one of the most important things is you have to make sure you have enough capacity. So you have to scale up the number of hosts in that cluster if you want to run more horizontal copies of your container. But then if you start to scale down, like for example during the night, and you're running fewer containers, you don't want to be running hosts that are sitting there doing nothing, because then you're paying money for a host that's underutilized. So right-sizing your cluster to the actual needs of your application becomes a challenge. So one of the things that we introduced at Amazon to solve this is AWS Fargate. So the idea with AWS Fargate is, once again, I can start with that high-level intention, which is to just run 10 copies of my container distributed across 3 AZs. I can give that intention to Amazon ECS, but then behind the scenes, I no longer need to manage a cluster of instances at all. Instead, my containers run directly inside of AWS Fargate, and AWS Fargate runs those 10 copies distributed. So at a high level, the AWS native container stack is made up of these 3 components. Amazon ECR is an image registry. highly scalable, which allows you to store all of your Docker images, your applications that you want to run, and store them right there on the data center where you plan to run them. Amazon ECS is a management interface, which allows you to control at a super high, 30,000 foot level, looking down. I would like to run this application. I would like to run this many copies, and just make it happen. I don't want to worry about the details. And then AWS Fargate is the hosting layer, which is what actually runs the application underneath the covers. So now that I've given this sort of introduction to what's available on the stack, I want to dive into the core concepts of Amazon AWS ECS a little bit to really show some of the constructs that we'll talk about later when it comes to console configuration. So the first construct to understand is the task definition. This is how you define your application that you would like to run and the parameters that it requires in order to run. So for example, the image URL where it's being stored right now in a registry, how much CPU and memory it needs, if there's any environment variables, if you want to customize the command that gets run inside the container at all, you would do that through the task definition. It's a version controlled metadata that describes how the application should be run when you say you would like to run it. Then there's the cluster. If you're running in EC2 mode, this isn't actually a physical group of EC2 instances. If you're running in Fargate mode, this is just a grouping construct to say, here's a bunch of resources that I want to run together inside of a single VPC. A task is a single running copy of one of those task definitions from earlier. And so it could have one application container in it, or it could have actually a couple different containers that are closely related. And so you'll see that that's how we apply Consul Connect to an ECS cluster, is we actually run an application container and a Consul Connect sidecar inside of a single task. But we want to run multiple copies of a task, and so the construct to accomplish that is called a service. So that's when I say I would like to run n copies of my task based on this task definition, and I'd like to keep them running. So if one of them has crashed, I want to restart it. Maybe I want to automatically scale that up and down based on a resource like CPU utilization and memory utilization. And I also want to be able to hook up the different copies of this task that were launched as part of that service to some sort of backing resource like a load balancer, for example. Now, obviously, if we're using a Consul Connect service mesh, though, we may actually not need a load balancer anymore. And so you'll see a little bit more explanation on that from Mishra. So at this point, I want to hand things over to Mishra to introduce Consul Connect and the basic details of Consul Connect and how to run it.
Thanks, Nathan. All right, I hope you all can see this. I'm going to full screen. Okay, so I'm going to give you kind of a brief introduction into Consul. Hopefully, you learn some of the ins and outs of how to deploy Consul, and then I'll talk about Connect in a bit. So Consul is our distributed service networking layer. It basically helps you connect, secure, and configure applications in runtime. With the latest release of Consul Connect last year, Consul became a fully functional service mesh, which is super cool. So before we dive into the ins and outs of service discovery and service configuration, I want to talk about some of the challenges that come with services today. We see services growing in number. We see them deployed in physical data centers, in on-prem data centers, in virtual machines in EC2 and containers and in Kubernetes, in EKS, and even in functions today, right? So this change is mostly due to this industry shift from monoliths to microservices, and it kind of brings in a lot of challenges. So when we break down the challenges and kind of give you three fundamental we come up with three fundamental solutions. Service discovery, service configuration, and service segmentation, which is basically what Consul is out to kind of solve and offer you. Service discovery, when I talk about service discovery, I mean service discovery between VMs and containers, VMs and VMs, VMs and on-prem data center, and so on. And kind of provide that registry that you can kind of register your applications in or functions in, and then use DNS or API interface to kind of get to that data. Then when I talk about service configuration, I mean, providing applications as some runtime configurations. And this might be a database URL or a database configuration and so on. And then when I talk about service segmentation, which means basically segment, a multi-tenant environment, a heterogeneous data center that we see with like a lot of different things, and provide some form of like, mutual TLS, kind of secure communications between two services or two VMs or two containers, whatever may be the case. And basically, these are the three main things that Consul kind of focuses on. So now I'll kind of go in depth on each one of these and talk about like how Consul exposes the data and like what's the actual use case here. So for service discovery, Consul has a really rich service catalog, which is kind of stores all the nodes that are running in the cluster and all the services that are registered with it. You can register a service using a plain text file, using a JSON configuration, or even using the HTTP API. So this information is exposed using a DNS interface that runs on every Consul agent. Every Consul agent exposes a local DNS server. So you can do dig queries like you see on the screen there with like web.service.consul. You get two ANAME records back with 0 TTL. If you want more interesting information or more rich information, you can use the HTTP API and get like things like the health check status and so on. So you can do much like interesting things with that data. All right, so service configuration. This is where like it gets super interesting. So Consul also is a distributed kind of a consistent key value store. What that means is basically it exposes a really simple, put and get API that you can kind of write keys into. So in this case, you'll be using the CLI to use kind of put few values in the key value store. And we're storing a Redis like connections flag. So here you see everything is prefixed. So in this case, we have Redis /config/connections. We're storing the value of 5 in there. And we are just using the same kind of prefix to get the value back. You can use the HTTP API as well. In this case, just to keep things simple, I'm using the CLI. And with the key value storage also comes this really interesting, really rich event system. So you can kind of watch for events in your cluster. In this case, I'm watching for a key change to that Redis config connections. So let's say someone updates the key from 5 to 10, then I can do an action. So in this case, I can run a bash script or something. But as you can clearly see, like this is super powerful and it's fully distributed. So what's interesting is like, you can watch for like things like feature flags or even do deployments across your grid based on an event and so on. And it also comes with some locking features as well. So you can say only 5 servers should deploy at a time and so on. So that's the service configuration part. And service segmentation is the newest kind of the feature that we've added called Consul Connect. This was added last year, I think, in the summer when Arman and Mitchell announced it at Hashi Days in Amsterdam. And so the idea with Connect is kind of provide service-to-service communication using mutual TLS and also provide an authorization layer on top. And I kind of go in depth as we go through these few slides here. So in this example, what I'm doing is basically using the CLI again and starting a Connect proxy and saying I want a sidecar for a service called Echo. So this service Echo might be running somewhere in the cluster, but in this case, let's say I'm logged into a service instance called web, some EC2 instance, and I've issued this command. What this would do is kind of expose a local port to Echo. In this case, the local port is 9191, and you see I'm doing a netcat, kind of command at the end of the example here, and I'm getting some few responses back. So if I like type hello, I get hello back. That's what the Echo service does. But this is all like over TLS and so on. And then the second thing you see in the screen in the middle is the Consul intention, the idea of intentions. That's the authorization layer. So in this case, I'm saying that the web service is allowed to talk to the Echo service. But if I say you kind of delete this intention or deny this intention, what would happen is the cert validation won't happen in mutual TLS, and you won't be able to establish a connection to the Echo service. And that's like kind of the gist of Connect. And I'll kind of go in depth into a kind of a real example in the next few slides here. All right, so before I jump into any of the Connect stuff, I just want to quickly give an overview of Consul's architecture. So Consul ships, like most of our HashiCorp tools, ships as a single binary. It has 2 modes. One's the server mode, one's the client mode. The server mode, basically the servers are like the brains of the operation here. They hold state. So they do some form of replication. They do a replication based on Raft. And then they also have leader election between them. So in this case, you see there's two servers that are the followers on the sides, and then at the center, you see the leader. And the clients run on all nodes. So the clients are, again, the lightweight part of the thing. They run on all nodes. This might be a web instance or a database and so on. And then they do this really lightweight gossip over LAN between them. So this kind of gives the cluster some form of membership. So a node joining or a node failing and so on, all that is kind of gossiped around using this gossip protocol. And then the clients, when they want to talk to the servers or get any information, like, let's say get results for that web service, they use RPC, and then they get to any of the servers, and the servers transparently basically request forward to the leader. So in this case, what happens is, like, you don't have to discover the leader. The clients don't have to be aware of the leader. They can just talk to any of the servers, and the request will transparently get forwarded to the leader, and the leader will respond to the client. So that's kind of the gist of the architecture. So when we talk about the service mesh, there's two parts, the control plane and the data plane. The control plane part are the servers, and then the data plane part are the clients, basically. So in terms of deployment, you can run the console servers on Amazon instances using EC2. You could actually run it on Kubernetes if you want, using a stateful set, and so on. So it's fairly flexible, and they do hold state. So you just need to make sure, like, you're backing up things and so on. But you can still run multiple copies of the servers to provide you with HA. On the client's side, on the data plane side, it's quite flexible. So you can run a client on a node, or you can run one per node and so on, and have multiple services register and so on. You can run clients in a container and so on. So in this case, we are running a traditional deployment in which you have an EC2 instance that's running the console client, and you have a service A. This might be a Ruby service or a PHP service, and that service is accessing the console API that the agent exposes on localhost 8500. You can change the port as you feel fit. But that's kind of the gist of, like, the services consuming all that nice data, like service discovery data, configuration, and so on, using that localhost API. So let's take an example in which let's kind of talk about two services, which is much more like real. We have multiple services in our data center. So in this case, let's say service A was talking to service B, and let's say the networking is set up okay. So you have security groups figured out, you have network ACLs and stuff, VPCs are good. In this case, service A is okay to talk to service B in terms of network. So let's say how you could use Console Connect to kind of do the whole thing, and we'll kind of go through the life cycle of the request. So in this case, we'll basically start a sidecar proxy, the Console Connect, the Console Connect sidecar proxy. This might be the built-in proxy or or Envoy or Nginx and so on. So what will happen is service A will just basically do a localhost call on a local port, which you can specify, or the service can specify, or the operators can specify, or you can ask Connect to kind of give you a dynamic port, console to give you a dynamic port. In this case, I'm specifying port 8080. So what would happen is the service A would just basically do a localhost call to the 8080 port, and then transparently, console will start a mutual TLS connection to the other side, in this case, to the service and the server that's running service B, and then also it'll take care of, like, generating the certificate, doing the validation and so on, and rotating the certificate as they expire and so on. And then on the other side, the sidecar proxy would terminate TLS and transparently forward the request. So service A is not really aware of, like, Connect doing all this. It's just talking on a localhost port, and everything just works. So in this case, we're assuming that the idea of an intention that I introduced in, like, I think a couple of slides ago, in this case, we're assuming that service A is okay to talk to service B. So let's say at some point, even though the networking is set up correctly, you just decide that you want to, deny the intention there. This mutual TLS connection won't be established, and you get, like, certificate invalid error or something. So that's, like, kind of the gist of Console Connect here. So there's few benefits of using Connect over, like, traditional load balancer, ELB or something. Is that, first of all, there's no, like, there's no code changes that are required on the application side. If you use the sidecars, it's basically something that's running alongside your application. You just configure your application to point to a port, your service dependencies that you expose locally, basically. And then you can enforce, like, identity, do mutual TLS fairly easily. And then also, you get, like, this idea of authorization on top of the encryption, which is super cool. So using intentions. And then you reduce the number of, like, load balancers that you might be running. You might have one per service and you have 50 services, so you might have 50 load balancers and so on. And you remove that extra hop that you get. In this case, you're just going from one service to the other. And the added latency and so on is removed using Console Connect. All right. So in terms of in the summary, the usage and kind of the journey that Console's on. So Console was launched in I think 2014. So it's been a while that it's been in production. It has over 12,000 GitHub stars, I think, and it's like a vanity metric in open source, but it kind of shows you some form of popularity that folks align with. And it gets around 1 million downloads monthly. And these are dedupe downloads. So these are unique downloads that we see. And we have customers that are running 50,000 agents plus on a single data center. So Console is multi-DC out of the box. In this case, the customers are running a single data center with 50,000 agents, which is a decent scale. And then Amazon was really nice to kind of let us know last reInvent, I think, that Console is actually the most widely deployed service discovery solution on AWS, which is super awesome. I think that's all I have for the Console side. So I'll let Nathan kind of demo a few ECS things and Fargate and kind of show you how Connect works with ECS and Fargate. And Nathan, I'll give it to you.
All right, show my screen. Okay. All right. So first of all, I want to show how you can follow along with this particular demo yourself, even after this webinar is over. So this particular demo of Console Connect Service Mesh, you can find it on containers on AWS.com. And so right over there under Architecture Patterns, you'll see Console Connect Service Mesh. And this will allow you to actually deploy this yourself. You can run it for 30 minutes, and it's only going to cost a couple dollars to play around with it. So this will allow you to have a playground to really experiment with Console Connect yourself. But this is the architecture we're actually going to be deploying today. And so you can see we have a standard AWS VPC with public subnet, a couple EC2 instances. And then on those instances, we're going to be running application containers. And each of those application containers is accompanied by a Console Connect sidecar. And that Console Connect sidecar is going to send traffic to the container. And if that container wants to talk to another container, it's going to be able to talk to that Console Connect sidecar. And the sidecar is going to route that traffic via another Console Connect sidecar to that other container that is the destination. And each of the Console Connect sidecars communicates with a console agent running on that host in order to find out and really discover where all the other containers are. So this is what allows us to have that direct container to container communication without needing to have a load balancer or anything else in the middle. So I've already went ahead and deployed a few of the starting pieces, the EC2 cluster and the console agent, just to save a little bit of time. So what we currently have set up is this. We have 3 EC2 instances, each running a console agent. And I want to show the task definition that makes that possible. So here you can see the console agent task definition that I've defined. And basically what it's doing is just running that standard console container with a few command line flags that's saying that I want to discover a console server based on its tag, and I want to be able to advertise that service and listen for incoming connections on port 8500, 8301, 8400, and 53. So port 8500 is the most interesting one for this demo. That's the port that is the console dashboard. So just to verify that we actually have console up and running, what I'm going to do is I'm going to open an SSH tunnel from my local machine to the machine on the AWS cloud, and it's going to forward traffic that goes to localhost port 8500 to port 8500 on this remote console running server. And so this will allow me to have access to the console dashboard as if it was on my local host, but really it's in the cloud. So this is just a more secure way to make sure that I can access that console dashboard without needing to open that port up to the world or anything like that. So here you can see that dashboard's up, and initially there's only one service on there, which is the console service itself. You can see I have some nodes. One node is the sort of leader of the console server. The other 3 nodes are the 3 hosts that will be running my data plane once I run services on them, and they're being orchestrated by ECS. So now let's actually run some services inside of this cluster. Now, I've prepared some templates to make it very easy to launch a simple architecture onto the cluster, and the architecture is going to look something like this. It's one service backed by two microservices. So there's a greeter task, and what it does is it assembles a randomized greeting phrase from a random greeting service and a random name service. So the greeting service is going to return something like, hi, hello, greetings, good afternoon. And then the name service is going to return a random name. The greeter task is going to combine those two together and return that phrase back to the public. And so I'm going to be using Consul Connect to route all this traffic around, because I don't want to have to keep track of where all my greeting tasks or all my name tasks are, especially if I'm scaling horizontally or vertically. I just want that Consul Connect sidecar to sit there in the middle and route that traffic. So let's go ahead and launch these services inside the cluster. I'm going to launch them using this handy CloudFormation launch link. And as this comes up, I'm going to click Next and name this one Greeting. And click Next, Next, Create Stack. And this one I'm going to launch is the name service, and I'll show what these templates look like in a second, so that way you can understand what they're creating. I'm using the template for now to be able to create the resources a little bit faster and more accurately without making any mistakes. Greeter. And create stack. Okay, so while that's launching, it only takes about 20 seconds or so. I'll go ahead and show what that template looks like. And I'll use the greeter service as an example, because this is the front-facing service that needs to talk to two backend services. So it's a good example of how to actually configure the Consul Connect sidecar. And once again, you can run through this demo yourself on containersonAWS.com. So you can actually access this template and see all the configuration and details yourself if you want to take your time reading through it. But basically, I'm running the Consul Connect proxy as one container inside my task definition, and I have another container, which is actually my application container, and that's this one. So for the proxy container, I'm starting the proxy with a few different commands to configure it, and what I'm saying is I want to listen on this local host, which in this case is a single task running outside that EC2 instance. And I specify two upstreams. And what an upstream is basically a way of saying, go out there and find instances of this remote name service, and go out and find instances of the remote greeting service, and expose that name service on localhost port 3001, expose the greeting service on localhost port 3002. And so my local application can now talk to localhost 3001, and any requests that it sends there will be forwarded through the Consul Connect sidecar to an instance of the name service, and that response will come back. And so you can see over here for my application container, I've configured these two environment variables that tell the application container where to find the name service and where to find the greeting service. And rather than having to plug in a application load balancer URL or some kind of hard-coded IP address where I can find that name service, instead I'm just pointing to localhost 3001, and that sidecar proxy is going out there and finding that and establishing that pipe for me. So now let's verify that this actually launched up. Let me go back to services, and sure enough, you can see in Consul, I have the greeter proxy. So this is the Consul Connect proxy in front of my greeter service. The greeting proxy, this is the proxy in front of my service that generates like hi, hello, and the name proxy, this is what returns a randomized name. So let's see if this is actually working. If I SSH into one of the hosts on my machine, go in here, oops. I want to establish a Consul Connect proxy locally on this host. So first, let me show that there's no services actually running on this host. So all this host is running is Consul itself. What I want to do is I want to launch Consul now, and I want to say I want to establish an upstream pipe to the greeter service, and I want to expose that on port 8001. So greeter and 8080. So I start this up, and I can do curl localhost 8080, and there you see a randomized greeting phrase and the IP addresses of the hosts that actually generate that. So the first one is the instance of the greeter, and then there's a greetings, and then there's a name. So if I rerun this a few times, you can see that it's returning all those random phrases, and you also see that there's different IP addresses. So Console Connect behind the scenes is magically and automatically load balancing across the different instances of my tasks. And if I click into a service, you can see that it knows all the different ones that were launched. And I can scale this up and scale it down in the Amazon ECS console as much as I want, and it'll go ahead and load balance across those. So hopefully this serves as a good introduction to how you can get started with Console Connect. And as I said, you can actually run this yourself and launch all these services. There's also an example of creating a public-facing ingress that can allow you to take traffic from the public and actually get it inside of the cluster via Console Connect to publicly expose a service that's inside of your cluster. So let me turn it back over to Mish for now, and he's going to show Cloudmap integration to tie your on-premise with AWS and discover resources across both of those.
Thank you, Nathan. All right, let's switch back. All right, I hope you all can see this. Okay, so we're going to talk about Console and Cloudmap, which is interesting. So Cloudmap, AWS Cloudmap, is a service that AWS launched last reInvent. And it's basically a really nice way to kind of expose service discovery data if you're running in an AWS environment. So this is basically a service catalog, very similar to Console, but that are built to kind of discover and kind of register any cloud resource that's running in AWS. So it might be a database or a function or a container or an EC2 instance. You can use Amazon APIs to register these things using CLI or the API. And then you can access this data using the APIs and Route 53 as well. And Cloudmap's built on top of Route 53 that kind of exposes DNS records to kind of discover those services. Again, very similar to Console's built-in DNS server as well. And I think Cloudmap has integrations with AppMesh. So AppMesh can kind of use Cloudmap to get that service discovery data and give you a service mesh in AWS. So when we talk about Cloudmap and Console, this is where things get interesting. So let's say you're in a hybrid environment. You have a few things running on-prem where you're running Console. You have another data center that's running Console, and you have a Amazon US West 1 data center that's running Console as well. So this is a fairly common use case for Console. Console is multi-DC out of the box, and it's been like that for 4+ years in production. So it's a very kind of familiar use case for Console. But with Cloudmap, what you get now is if you're running an AWS environment, we can sync all the services that are running in Console into Cloudmap and vice versa. So services in Cloudmap would also show up in Console, which is super amazing. So what you essentially get is a way to discover things from the cloud into on-prem or from on-prem out to the cloud, which is super awesome. And this is due to engineering efforts between HashiCorp and AWS. We worked together to come up with a project called Console AWS, which gives you this bi-directional sync. I'll kind of showcase a demo to kind of do this all. And unlike Nathan, I'm not going to be doing a live demo. I love live demos, but not in this case. It's a bit complicated, and just for time, I just wanted to make sure I use a recorded demo. But I'll basically speak over the demo here. Okay, so here what I have is a namespace called HashiCorp.live that's created in the Cloudmap UI. Here, this namespace really doesn't have anything yet. You can kind of use API or public DNS queries to kind of get to services in this namespace, but currently it doesn't have much. We haven't created any service yet. So I'll quickly show you the Route 53 management console. This is kind of the background behind Cloudmap. Here you see when you create a hosted zone in AWS, you get a set of name servers and an SOA record, and that's what you see here. So there's nothing created yet. Okay, now what we do is if we switch to the AWS instance here. So what we are trying to do here is in this demo is that we're connecting an AWS instance and kind of using VPNs to connect an on-prem data center into AWS. So we are assuming that networking is working. You're using Direct Connect or Transit Gateways or your own custom VPN to do this. But we are assuming that works, and we're going to connect an EC2 instance to two Redis databases that are running on-prem. These Redis databases won't be clustered in any way. So in this case, I'm just showing you that this is a real EC2 instance with a VPC address there, and then the really crazy looking interface that you see at the end there is the VPN really with that 10.6.6 IP address. This is my on-prem Redis databases. I'm going to mirror both commands in both screens in places. And here you can see that, again, the IP address is different. This is a separate network namespace, and I just want to make sure that we aren't really faking anything. This is like a real setup for on-prem situation. So here again, you see the same interface at the end with 10.6 IP address. Now I'll just do a Redis CLI command just to show you that these are real Redis servers. They don't have anything in them, and they aren't clustered in any way, just to keep things simple. Okay, and then we're also running Consul on-prem. So in this case, Consul is like powering the service discovery on-prem, and Cloudmap is powering the service discovery in AWS. And you'll see how that kind of works. So in this case, I'll just do a Consul members to show you that there's 3 Consul servers that are running, and the 2 database instances that are also running the agents in client mode, and they're the ones that are going to register our services for us. So now, if we switch back to the 2 Redis servers, we can just use plain text files to register this DB service that we're going to use. The DB service is going to basically encompass the 2 Redis servers that are running in these 2 instances. And you see I have a health check associated with it, which is just a simple bash script. And this bash script basically does a Redis ping, and it gets Pong as a response back. So just to keep things simple again. So now if we switch back to the console UI and then go to the services tab, you see we have the DB service registered with 2 DB instances that are active and running and passing health checks. Okay, so now what we'll do is we'll kind of show how we can start the syncing process in this case. So now if we switch to our console server here, and we'll start this process, and this is the tool that ships alongside console here, the console AWS, and this is what we worked on to kind of make this bidirectional sync process available. So in this case, we're just going to sync catalog to AWS and to consoles, which is the bidirectional sync. And then we're providing the AWS namespace ID, which is a HashiCorp.live domain, and the namespace ID for that. And then we're just piping some logs into the log file here, just to keep things simple again. We'll start this bidirectional sync process. We'll switch back to Cloudmap. We will refresh our screen, and you'll see that we have 2 services that were in console now showing up in Cloudmap. And we have the console service and then the DB service, and both have description imported from console. Now, if you open up the DB instances, you'll see there's 2 instances of these things running. These are the 2 on-prem data centers, databases with the IPs, the correct IPs, and the port, which we can now discover using DNS if you'd like. So now, if you switch to an Amazon instance and just do a dig for db.hashicorp.live, what you get back is 2 DNS entries with ANAME records with a certain TTL that you can configure. In this case, it's the 2 IPs, and these are the IPs that you can kind of get direct access to those instances using the VPN here. So now what we'll do is we'll actually try to do that. Let's use Redis CLI on this end on AWS and provide the host name, which is our Cloudmap powered host name, and which is basically using the sync process there to kind of get that service discovery data from console, which is running on-prem. We'll run this command, do an info, and we can get to those instances on-prem, which is super easy. Now what we'll do is we'll do something interesting and do something I guess destructive. We'll switch back to one of the Redis servers, and we'll just shut that server down. What that will do is basically stop the console agent as the machine shuts down. So it'll deregister the node, which means it'll deregister all the services that are running on that node. In this case, it's just running the DB service, which is the Redis server. So now if you switch back to the console UI and look for the DB service, and you'll see there's only one instance. So basically what has happened is the node is deregistered, the health checks have failed, and the DB2 is basically gone. So now what we'll do is, since this bidirectional sync process is going on in the background and it's pretty immediate, if we refresh our screen here, what we see is that we'll have only one service instance that we can kind of see in the Cloudmap UI. And if we do a dig record, do a dig query from the AWS environment, you should get one record back from AWS. In this case, TTLs might play a role. In this case, we got lucky and we got one any record back, basically. So you can set lower TTLs to kind of enable the immediate kind of failover. And we'll try to get to the Redis server again from AWS, and we are still good because we're using the health checking. We're making sure we just have at least 2 of the copies for the Redis server running. Okay, so now what we'll do is we'll kind of do the sync from AWS into console. So basically from your cloud environment onto your on-premise data center. So if we go to create a new service in Cloudmap, we'll just use the UI again, just to keep things simple, but you can use a CLI or the HTTP API to create these services if you like, using AWS. So here we're providing a service name called web. We're just giving it a description, and then we'll basically make this an A record type service with no health checks, just to keep things simple again. We've created the service. Now what we'll do is we'll create instances of that service. So these are the actual service instances that are under this higher level notion of service. Here we need to provide an instance ID. So we'll just name it web1, and we'll also provide an IP address. The IP address in this case being this EC2 instance, even though it's not running any service on it. But just to keep things simple again. So yeah, we paste that IP address in, and we'll put a port, which is optional. And we'll create the service instance. So what this has done is basically created a service, or simulated a creation of a service on the AWS side. So you can use the CLI again, you can use the API, do it automatically. It doesn't have to be a manual process. But just to show this demo, I just kept it simple. So now if we switch back to our on-premise Redis servers, we can actually use this kind of data, which is bidirectionally synced into console. So now in the console UI, if you see, we see a new service called web, and you'll notice that it has a really nice small logo, the AWS logo on it. So these are all kind of services that are registered externally using AWS. That's why it says registered using AWS, just to make sure that people understand that console on this end isn't controlling the service in any way. It's very much a one-way sync in this case, and it's also providing you with the right IP address and so on. So now let's consume the service using our on-prem database, and we'll use this the local DNS server that I was talking about. So every agent, the client agent, is exposing a DNS server on port 8600 by default. You can change the port if you like. You can use things like DNS mask to kind of get rid of that and transparently forward everything to console. And console can kind of delegate the TLDs and so on. In this case, we're doing a web lookup. So we're using the console, a way of kind of looking up something. In this case, we're using web.service.console. So in console, we use the way you kind of look up DNS entries is we provide the name of the service you want to look up. In this case is web. The type of the thing you want to look up. In this case, we're looking for a service. You can also look up for a node if you like. And then .console is the high level TLD, which is configurable to your company name or so on. So once you do that, what you get back is a 0 TTL entry for 10.0.0.84, which is the IP address of the AWS instance. We're discovering this using an on-prem setup here, and you also get this additional section of answer back from the DNS server, which provides you with a TXT field for all the tags that are associated with the service, in this case being the external source AWS. So that's basically it. And that's console and Cloudmap, which is super interesting. It kind of lets you, bridge all the service discovery things and give you a kind of a unified view of your data center, really. So you can use Cloudmap, or you can use console as the consuming end, but you can kind of mix and match as you like and so on, since console runs pretty much everywhere. So I think that was it in terms of the demos for us. And I think we can do questions now.
Thank you, Mishra, and thank you, Nathan. So yeah, we're going to open it up for questions. So at this time, go ahead and enter any questions that you have into the chat box. We've already had a couple come in. So Nathan, this one was an AWS specific one. Is there any TA for Windows nodes being available on Fargate?
Nothing that I can share currently. What I would recommend though is we have a public roadmap now actually for containers, and so I believe that is one of the items on there. We have it sort of organized into buckets where it's like working on it right now or it's coming up. I don't remember in particular which bucket that's in right now, but definitely check that that public roadmap for containers. It's a new sort of experiment, and you can actually suggest things you would like to be on that roadmap as well. So feel free to check that out.
Cool, thank you. So question, I can send this to both of you. So should the console servers be backed by a load balancer for high availability, since it may become a potential single point of failure? What's the recommended approach for that?
I can take this, Nathan, and then maybe you can add on to it. So the console, the HTTP API is actually exposed by the agents locally. So there's no need of like a load balancer to access the API really. So the client agents are running that API by default on 8500. It's only bound to localhost. You can bind it to an external port if you like, an external interface if you like, but by default it's localhost. So all the applications sitting on a node will use localhost to get to that local agent API, and the agent does all the heavy lifting for you, really. It does all the RPC requests up to the servers. It discovers like one of the servers. It does multiplexing and so on, and it kind of helps like ease that pain off the applications. Don't have to like do any like load balancing and so on. And then the interesting part though is by default, if you're doing service discovery, let's say, and you're trying to look up a service, what would happen is you'd get 0 TTL, which is what you were seeing in those DNS results, which means it's the data copy that you're getting back from the servers is actually fresh and it's coming from the leader. And let's say you have a service that's high read, focused on reads and so on. You might need to tune the TTL. So in this case, like let's say you can take a hit for like 5 seconds. It'll improve your performance like dramatically, because at this point, you're caching some of these things, and even the followers can kind of return back that cached TTL value and so on. So yeah, that's where you kind of pick and choose. But by default, you should be good for like a decent amount of throughput, and as you grow, you can kind of tune that flag. It's completely like pretty much every option there is like configurable.
And to add to that, in the actual demo that I showed earlier, I showed it very briefly, but feel free to go in there and actually look at that template some more. I'm actually discovering the central console server using an EC2 tag. And so what's happening is when I launch that console server, it's tagged with a tag that says this is the console server to find. And then all those individual console agents on each host, they go out there and they look up that tag and they find that machine and connect to it. And so what that allows me to do is I can run a couple different console servers. And as mentioned before, they establish that gossip, and they perform like a HA cluster. And then whichever one is available, discovered by that tag, the console agent will connect to it. And so you can actually get that high availability without needing a load balancer, because it'll go out there and discover it based on the tag.
Thank you both. Mishra, I think this one is more for you. So how are the certificates for mutual TLS managed? Are they self-signed or rotated on a given frequency?
Yeah, so by default, you get the built-in CA. So let's say you don't specify. So console, actually, I'll backtrack and talk about like the CA actually. So if you don't specify CA authority, in which case, let's say you're not using something like Vault, or you're not providing a CA authority in the console config, by default, you get the built-in CA. So console is, as part of Connect, is a built-in CA. So it ships with it. In that case, console will generate the certificates and also store the root certificate and private key on the console servers. But it can be configured to provide a custom certificate, custom root cert, private key, and so on to generate your certs and so on. And then let's say you want to rotate certificates, and let's say you're moving the provider. In that case, we've built a way to kind of you can read more on the console website, kind of in depth on the exact rotation process. But what we've done is that you can kind of add a provider and then basically smoothly transition from the old certificate to the new certificate. And we do this by using cross-signing certificates and so on. And there's a full detailed section on the Consul website if you look up root certificate rotation or something, if I remember correctly. And you can kind of go through on how that rotation process is implemented. So in summary, by default, there's a built-in CA which generates its own certs if you don't provide them with the root cert and the private key and so on, but you can provide them, and then Consul will take care of the rest. And then you can actually use a provider that's like separate from Consul, built-in CA. So that's like fully pluggable. It could be Vault, it could be your own CA authority.
Thank you, Mishra. Nathan, we had a couple questions come in about the differences between Fargate and Cloudmap. Could you kind of give some ideas of what the differences between the two are and when you would want to use each, or should you be using both?
Mm-hmm. Yeah, so Fargate, as I mentioned earlier in the deck, is actually the hosting layer. So that's where I upload my container and say I would like this container to run inside Fargate. And so you can think about Fargate as just like with EC2, you can ask EC2 for a VM and you get a VM to run your code. With Fargate, you ask Fargate for a container and it just runs that container. So by itself, Fargate is literally just something that runs your stuff. It's just compute. Now, Cloudmap, what it does is it enables you to keep track of all the different containers that you're running inside Fargate, as well as keep track of all of the other resources you might have, whether they're Redis or database or whatever. And so in a similar way to Consul, it's a list of all the resources that are available on your account, and it does health checks against them. So what you could do is you could run 10 copies of a container inside Fargate, and Fargate is providing the compute, but then Cloudmap is pinging each of those containers to make sure that they're healthy and alive and running. And if they are, then it's keeping that list available. And so where that ties into Consul is then Consul can access that list and sync it into Consul itself to provide an easy DNS interface or an easy way to get that information into your on-premise data center or similar. So basically the way to think about it is Fargate provides the compute, Cloudmap keeps track of where everything is running and whether or not it's healthy.
Thank you. Mishra, we had a question come in about the Consul dashboard. Can it show observability metrics for Consul Connect?
So not yet, no. So that's one of the features I think that we don't have yet. So Consul Connect right now is focused on layer 4 really. So there's no interesting HTTP data and so on. But we do have integration with Envoy. So kind of Envoy by default exposes a set of metrics. So these are like stats-D things and Prometheus metrics and so on. I think you can kind of configure Envoy to ship that for you. So currently, Consul UI itself doesn't have any, direct observability metrics on like service-to-service communication. But I'm not sure if it's scoped. I think it might be scoped for one of the big major releases.
Thank you. So Nathan, we had a question come in about someone who's currently using EKS, and so they were kind of curious about what the benefits of using either ECS or Fargate versus like EKS is. Could you maybe talk a little bit about the differences between those services?
Yeah, sure. So ECS and Fargate, currently Fargate is only available for ECS, not for EKS. So if you want to have that simplicity of saying, I just want to run my containers and not have to worry about the underlying infrastructure that they're running on, you should probably use ECS for that. The difference beyond that between ECS and Kubernetes is that ECS is much more focused on externalizing the different resources outside of where your application runs. And so what I mean by that is everything kind of runs behind the curtains of AWS, and it's offloaded from your application infrastructure. So when you provision, for example, an EC2 host or a Fargate container to run your application, you get 100% basically of the resources of that machine. Versus what Kubernetes is designed to run more on the node. And so your EC2 instance has a lot more resources running on it. A lot of the things that you run are, for example, open source plugins to do things like provision the load balancer, or you run a lot of end up running a lot of stuff like Istio, sidecars, stuff like that inside Kubernetes cluster. Versus ECS is more designed for you just provide the compute container that you would like to run, and then AWS takes care of all the heavy lifting around it and hooking up everything to your cluster. So I would say if you want to go all in on AWS and you want to use AWS resources to sort of simplify your life, then ECS makes it a lot easier for you right now. If you want to have that cross-cloud compatibility, or you have an on-premise workload, you want to make sure you can easily migrate to and from the cloud, Kubernetes is easier for that because it allows you to run it yourself locally as well as in the cloud. But really, as you compare it yourself, you'll see that a lot of the fundamentals and details of how it works is pretty much the same. It maps over. So it comes down to your preference and your needs in terms of portability.
Excellent, thank you. So we did have a question come in. Mishra, are there Terraform templates available for spinning up Consul?
Yeah, I think there's a very detailed guide as well. So I think I would recommend, folks, I think this is kind of maybe not directly answering the question, but I would recommend folks to check out learn.hashicorp.com. It has, this is a new training platform, not training platform, but learn platform that we've released, which kind of gives you two views. So one's the beginner view, in which you just want to kind of play with Consul, understand the high level concepts and so on. And then there's an advanced mode in which you can kind of go in depth and do the ACL system, connect and so on. And that'll give you a good idea of how to productionize it and so on. It has a production checklist and so on. So I think that's the right way to approach learning. And then HashiCorp has a few different guides that are on GitHub that you can kind of use, download. There's a GitHub, there's I think Terraform modules that you can find, which basically enable you to spin up Consul on AWS.
And one more question for you, Mishra. So we had a question come in about migrating to ACL Consul from non-ACL. What's the best way to do that with reducing downtime?
So I think the ACL system, to enable the ACL system, I would recommend following one of the guides that we have for ACL system. I don't want to I can't predict the way the Consul is kind of set up for your organization, but in most cases, we would start with kind of figuring out which would be your authoritative ACL data center. So you need to kind of say that this one data center, since Consul is a multi-DC out of the box tool, you'll have to figure out which DC is going to be your authoritative ACL data center. Once you do, you kind of basically make that as your make those servers enable ACL system. Provide them with the ACL kind of I think the first key that you generate. Once that's active, then you slowly roll it out to other DCs and so on. But in depth, I would basically recommend the users to check out the ACL guide and see what works for them, and then kind of give us feedback.
Thank you. And we did have no one more that came in. So can Consul discover traditional networking devices? So Cisco equipment, for instance.
Okay, so that's an interesting one. So one of the projects that we don't really talk about is this thing called Consul ESM. It's fully open source again. It's another one of these helper projects that we worked on for one of our customers for I think an enterprise use case, and then eventually open sourced it, which is super cool. So Consul ESM kind of lets you register services that aren't able to run a Consul agent, because you might need an agent to kind of register a service. So what this lets you do is kind of make one of your nodes or two of your nodes as the external nodes in your cluster, and then use Consul ESM to sync and do health checking on those services, and then kind of get that service discovery data, and then put that in the catalog. And that's one way of doing it. The other way, if you don't want this sophisticated kind of ESM process doing all this, you can just register a service as an external service, but it won't have any health checks. So you can just say that this network interface exists, and then we just assume that this network interface is available always, which is not a good assumption. But I think you can do that to kind of start off and then try the ESM process. And you can search for Consul ESM. And I think there's a blog post done by Christy, who works with me on my team, I think. And she's kind of laid out how ESM works and so on.
Well, thank you, Nathan. Thank you, Mishra. We had some great questions from the audience. I hope everyone enjoyed today's webinar and have a better understanding of how you can use Consul to manage containers and microservices on AWS using AWS services. I want to thank you for joining, and a big thank you to Nathan and Mishra for taking the time today and doing the demos and answering questions. I also want to mention that HashiCorp is hiring. So if you like what you heard today, please take a look at our jobs page at hashicorp.com/jobs and see if there might be a fit for you. And finally, as I mentioned at the beginning of the webinar, this webinar was recorded. We will be making the recording available on our website after processing, and I will also be sending out an email to everyone who registered with the recording link. You can keep an eye out on Twitter, where we'll post the recording link there as well. And I want to say have a great day. Bye, everybody.
Everyone.
Thank you.